Between 1970 and 1990, a quiet revolution happened in farm fields that most people never saw. Farmers were using machines with onboard computers, electronic sensors, and GPS-like guidance systems decades before smartphones existed. Engineers were solving precision agriculture problems in 1978 that Silicon Valley is still trying to perfect today. These 10 machines didn't just work, they were 30 years ahead of their time. Number 1. The John Deere 8640 4WD Articulated Tractor, 1979. Why this tractor was different? In 1979, John Deere introduced the 8640, a 275 horsepower four-wheel drive articulated tractor that weighed over 30,000 pounds and could pull implements at speeds and field efficiencies that were simply unimaginable in earlier decades. But raw horsepower wasn't what made the 8640 remarkable. It was the engineering philosophy behind it. The 8640 used an articulated frame, meaning the tractor bent in the middle to steer rather than relying on front-wheel steering alone. This allowed 4 large, equal-sized drive wheels to stay on the ground continuously, spreading the machine's massive weight more evenly and dramatically reducing soil compaction compared to conventional tractors with smaller front wheels. The compaction problem nobody talked about. Soil compaction from heavy machinery was already understood by soil scientists in the 1970s, but most tractor manufacturers hadn't fully addressed it. The 8640's equal-wheel, articulated design was a direct engineering response to this problem, one that soil scientists today identify as one of the most important factors in long-term farm productivity. Modern autonomous electric tractors from companies like Monarch and AGCO still prioritize low soil pressure as a core design spec, building directly on what Deere was wrestling with in 1979. The 8640 also featured a sound guard body cab, a fully enclosed, pressurized, air-conditioned and heated operator environment with noise levels low enough for normal conversation. In 1979, this was extraordinary. Modern tractor cab ergonomic standards trace directly back to the sound guard concept. Number 2. The Dutz Alles 8070 Air-Cooled Tractor, 1980s. Eliminating the radiator? German manufacturer Deutz had been building air-cooled diesel tractor engines since the 1950s, but their technology reached a peak of sophistication during the 1970s with the models sold in North America under the Dutz Alles brand. The concept sounds simple, cool the engine with air rather than liquid, but the engineering implications were profound. Air-cooled engines eliminated the radiator, coolant system, thermostat, water pump, and associated hoses and clamps. In a farming environment where machinery operates in extreme dust, debris, and temperature swings, each of these eliminated components was one less thing to fail. The Deutz air-cooled engines were also significantly lighter and could operate in temperatures that would overheat conventional water-cooled engines, decades ahead in reliability engineering. The reliability philosophy behind the Deutz air-cooled design, minimize components, minimize failure points, is precisely the same principle driving modern electric tractor development. Electric drivetrains have roughly 20 moving parts compared to hundreds in a diesel engine. Deutz engineers in the 1970s were chasing the same goal through different means: maximum uptime in the field, minimum maintenance downtime. Their Dutz Alles 8070 model, rated at 170 PTO horsepower, remained competitive well into the late 1980s and has a devoted following among farmers and collectors today for its exceptional durability. Number 3. The Gleaner N6 and L2 Combine Harvesters, 1970s-1980s. The Rotary Revolution. In the mid-1970s, Alice Chalmers introduced the Gleaner Rotary Combine, a fundamentally different approach to separating grain from crop material. Traditional combines used a cylinder and concave threshing mechanism, followed by a series of straw walkers, long reciprocating sieves that shuffled straw back and forth to shake out remaining grain. It worked, but it was mechanically complex and limited capacity. The Gleaner's rotary system used a large diameter longitudinally mounted rotor that spun crop material in a helical path through a cylindrical cage. Grain fell through perforations while straw was expelled from the rear. The result was fewer moving parts, higher throughput capacity, and significantly better grain separation efficiency. especially in tough, green or tangled crops where conventional walkers struggled. The technology that took over the industry. Today, the rotary combine is the dominant design in large-scale grain harvesting worldwide. John Deere's STS rotor, Case IH's axial flow, and New Holland's CR twin rotor combines. The machines harvesting the majority of the world's corn, soybeans, and wheat all descend from the rotary principle that Gleaner and International Harvester were pioneering in the 1970s. The Gleaner didn't just build a better combine, it redefined what a combine could be. Number 4. The International Harvester 3788 2+2 tractor, 1979. Four-wheel drive without the four-wheel drive price. International Harvester's 3788 2+2, introduced in 1979, was one of the most unusual tractor designs ever built. IH's engineers wanted to offer farmers the traction and power of four-wheel drive at a price closer to a conventional two-wheel drive tractor. Their solution was genuinely ingenious. They created an articulated tractor that put the engine and front axle ahead of the articulation point and the cab and rear axle behind it. Unlike conventional four-wheel drive tractors, where all four wheels were approximately the same size, the 2+2 had large rear wheels and smaller front drive wheels, but both axles powered. The cab sat over the rear axle with exceptional visibility forward. The articulation gave it the maneuverability of a smaller tractor while maintaining the pulling power of a large four-wheel drive machine. Ahead of its time in concept, the 2+2's approach, packaging maximum power and traction into a nimble, cost-effective platform, is exactly what modern compact utility and specialty tractor designers are chasing today. The 3788 generated up to 186 drawbar horsepower, competitive with machines costing significantly more. It was discontinued when IH was acquired by Tenneco in 1985, but its engineering approach influenced IH's Case successors for years. Number 5. The Ropa self-propelled sprayer, late 1970s. The birth of high-clearance application. Chemical application in the 1960s and early 1970s was done primarily with tractor-mounted or pull-type sprayers that required a tractor to drive through crops, damaging them and compressing soil between rows. The dedicated self-propelled high-clearance sprayer, which emerged in commercial form in the late 1970s from manufacturers including Roper, Hagee, and later Sprayer, addressed this problem directly. These machines rode on tall, narrow wheels that could straddle crop rows, with the chassis elevated high enough to clear standing corn or soybeans. The spray boom, sometimes 60 feet or more wide, folded hydraulically for road transport. Application rate was controlled mechanically, and the operator could cover 100 or more acres per hour. The foundation of precision application. What made these sprayers ahead of their time was the philosophy of application precision, delivering the right amount of chemical exactly where the crop needed it, minimizing waste and runoff. By the late 1980s, some sprayers were being fitted with early electronic rate controllers that could automatically adjust application based on ground speed. This is the direct foundation of modern variable rate application technology, which uses GPS and prescription maps to vary input rates across a field in real time. The 1970s high-clearance sprayer laid the infrastructure that Precision Ag plugged its electronics into. Number 6. The White Planter 5/1000 Series, 1980s. Electronic seed monitoring. White Farm Equipment's 5100 series planter, produced through the late 1970s, was among the first production planters to incorporate electronic seed monitoring systems. Optical sensors in each row unit detected individual seeds as they dropped through the seed tube, and a cab-mounted monitor displayed planting population and flagged skips or doubles in real time. Before this technology, a farmer had no way of knowing if a row unit had plugged, run out of seed, or was planting at the wrong population until they walked the field after the fact, often too late to replant. The White Planter monitor allowed operators to catch problems within seconds of them occurring, reducing yield loss from planting errors. The first step toward planter automation, the White 5100's electronic monitoring was the embryonic form of what is now one of the most sophisticated data collection systems on a modern farm. Today's planters from John Deere, Kinsey, and Precision Planting record every single seed, its precise location, spacing uniformity, and depth, tied to GPS coordinates and uploaded automatically to farm management software. It all started with the optical seed sensor that White was fitting to planters in the late 1970s. The concept was identical, only the sophistication of execution has changed. Number 7. The versatile 895 bi-directional tractor. 1978. A tractor that drove both ways. Canadian manufacturer Versatile introduced one of the most radical tractor concepts of the 20th century in 1978, the bi-directional tractor. The concept was straightforward but audacious. A tractor with identical controls and performance capability in both forward and reverse directions, with a cab that could rotate 180 degrees to face either direction of travel. The Versatile 895 bi-directional used a four-wheel drive articulated chassis, where all four wheels were the same size. The engine was mounted centrally, and the cab swiveled on a turret. Running the tractor in the conventional forward direction, it operated like a standard four-wheel drive tractor. Rotating the cab and running in reverse, the operator now had a front-loader tractor with full forward visibility and identical drawbar capability. No rear visibility problems, no awkward positioning, solving the loader problem decades early. The bi-directional's core insight: that loader work is inefficient because operators are always looking backward when they need to see forward, is still a recognized problem in agricultural engineering. Modern telehandlers and articulated loaders try to address it with long boom designs. The Versatile solution was arguably more elegant. The bi-directional was produced until 1990 and later continued under the New Holland brand. It remains one of the most genuinely original tractor designs in history. Number 8. The John Deere 7721 Titan Combine, 1979, the largest production combine of its era. When John Deere introduced the 7721 Titan Combine in 1979, it was the largest production combine harvester in the world. With a 240 horsepower engine, a 24-foot header, and a grain tank holding 180 bushels, the 7721 was designed for the large-scale grain farms of the U.S. Midwest and Great Plains that were expanding rapidly in the 1970s due to high commodity prices and growing global food demand. The 7721 also introduced Deere's cylinder speed control system, an adjustable threshing cylinder that allowed the operator to tune cylinder speed from the cab to match different crop conditions. Wet corn needed a different speed than dry wheat. The ability to adjust this setting without stopping the machine was a significant productivity advance. The data collecting combine. By the early 1980s, Deere was fitting Titan series combines with electronic monitoring systems, the Combine Performance Monitor, that tracked fuel consumption, grain losses at the sieves and walkers, engine load and ground speed. A display in the cab gave the operator real-time feedback on machine efficiency, allowing them to optimize header height and ground speed for minimum grain loss. This was early precision agriculture data collection. A decade before GPS made field mapping possible, the Titan was building the feedback loop farming philosophy that satellite-guided variable rate technology would later expand exponentially. Number 9. The Case 2090 and 2290 Tractor Series, 1978-1983, Black Beauty and Real Engineering. J.I. Case Company's 2090 and 2290 tractors, produced from 1978 through the early 1980s and immediately identifiable by their distinctive black engine hood, represented some of the most technically refined conventional two-wheel drive tractors of the era. The 2290, rated at 219 engine horsepower and 181 PTO horsepower, was among the most powerful two-wheel drive row crop tractors ever built. But the engineering that made these tractors remarkable went beyond horsepower. Case fitted the 2090 and 2290 with their advanced comfort system cab, a cab mounted on rubber isolators that dramatically reduced vibration transmission from the tractor frame to the operator. Hydraulic steering was standard, requiring minimal effort. The transmission used a fully synchronized power shift that allowed on-the-go gear changes under load without clutching. Operator health as an engineering priority. Whole body vibration from tractor operation was recognized as a serious occupational health concern by European agricultural engineering researchers in the 1970s. The vibration isolation cab that Case developed for the 2090 and 2290 was a direct response to this research. Today, whole-body vibration standards for agricultural machinery operators are regulated across the European Union, and every tractor manufactured globally is engineered to meet these standards. Case was addressing this problem in production machines in 1978, over 2 decades before it became a regulatory requirement. Number 10. The Ag-Chem RoGator self-propelled applicator. Late 1980s, the machine that invented variable rate application. Ag-Chem Equipment Company of Minnesota introduced the RoGator self-propelled applicator in the late 1980s as an evolution of the high-clearance sprayer concept, a purpose-built, high-speed, high-clearance machine for liquid and dry fertilizer application. But the RoGator's most important contribution wasn't the machine itself. It was what Ag-Chem engineers began connecting to it. In the late 1980s, as GPS technology was becoming available to civilian applications, Ag-Chem engineers began experimenting with linking GPS position data to application rate controllers on the RoGator. The idea was to create a prescription map, a digital map of a field where each zone had a prescribed input rate based on soil sampling data, and have the machine automatically adjust its application rate as it moved across the field. The birth of precision agriculture. This work, conducted in the late 1980s and commercialized in the early 1990s, is widely recognized as the foundational development of variable rate technology, the core of what we now call precision agriculture. Ag-Chem's RoGator was the first commercially available platform for this technology. Every variable rate applicator, every prescription planting map, every GPS-guided input management system in use today, across hundreds of millions of acres worldwide, traces its commercial lineage directly back to the experiments Ag-Chem's engineers were running on RoGator applicators in fields across Minnesota and Iowa in the late 90s. Axio, which now owns the Ag-Chem brand, still produces the RoGator line. It is one of the few machines in agricultural history where the original product name has survived continuous production across 4 decades, because the machine so thoroughly defined its category. If this opened your eyes to the engineering history hiding in farm fields, subscribe and ring the bell. Next week, we go even deeper into the machines that quietly built the modern world.